reducing its size. But there's nothing imaginary about its effects on our Earth. Of all the hidden lunar mysteries, there's one that can be observed right here on Earth. It may be the most influential phenomena that can be attributed to the moon.
From our place on Earth, tides just appear to be the times of day when the sea rises and falls. But that's an interaction, a gravitational interaction between the moon and the Earth. So when the moon is passing by, it pulls on the oceans and pulls it up higher, and we see it as a high tide.
The ocean tides are caused by the gravitational pull of the sun and our moon.
The sun and the moon both pull on the Earth and contribute to tides, but the moon is much closer, so its pull of gravity is felt more strongly than the sun's.
Oceanographer Tatyana Ross says the moon's constant tug on the Earth is formidable.
The reason that the moon's influence is so visible in the form of tides is because water can run, it can move, it's malleable.
In a remote bay in Canada, one community has learned to live with mysterious and extreme ocean tides that are found nowhere else on Earth. While normal tides rise by an average of 3 feet, the waters along the Bay of Fundy between Nova Scotia and New Brunswick swell up to 50 feet twice every day.
One of the reasons the Bay of Fundy has such large tides is because of the shape of the landform underneath the bay. It's kind of a funnel shape, and so as the water level rises, it really rises rapidly.
At high tide, 100 billion tons of water sloshes into the bay in a matter of hours. Then during low tide, most of it drains out like a bathtub.
The bay is shaped just so that the first tide comes in like a wave and it moves along, deflects off the back, and it comes out to the mouth just at the same time as the next tide has built up. And so they add up in a thing called resonance.
Tidal resonance is just getting the rise of the high tides to coincide. Certain wavelengths are reflected in a way that they reinforce each other and amplify each other, and the tide is therefore amplified.
The unique funnel shape of the Bay of Fundy contributes to this resonance and the height of its tides. The bay gradually splits into a series of basins and river junctions that restricts the tidal flow and contributes to the extraordinary tides. Tides, one more way our planet is forever tied to the moon, but it doesn't end there. We know that the moon's gravity is constantly pulling up on the Earth's oceans, while the Earth's gravity pulls down on the moon.
Everything in space is tugging on everything else. So the Earth is tugging on the moon, and the moon is tugging on the Earth.
The moon's gravitational pull on our oceans is so powerful that it creates what's called a tidal bulge on both sides of the planet.
The moon pulls on the Earth gravitationally, and when it does so, it also pulls on the oceans that are sort of stretched up a little bit toward it. It pulls preferentially on the front side of the Earth, pulls the ocean toward it, then pulls the Earth a little bit less, and then the back side, the ocean is not pulled quite as far toward the moon. So that's why there are two bulges. They're called tidal bulges on the Earth.
Tidal bulges on our vast oceans actually impact the Earth's rotation.
This tidal bulge that's created by the moon, it's moving out ahead of the moon a little bit, and the moon is actually pulling back on this tidal bulge. Now when the moon pulls back on this tidal bulge, that slows the Earth down.
Without our moon, the Earth would spin much faster and our days would be much shorter. And this would affect how life has evolved on this planet. But these These tidal forces, which tie the Earth to the Moon, travel a two-way street. Our Earth also has an undeniable effect on the Moon. So if the Moon had water on it, would the Earth's gravitational pull cause similar tides on lunar oceans? The answer is yes. In fact, billions of years ago, the Moon was almost entirely made up of liquid, but not water.
When the Moon was first formed and very young, it was entirely liquid rock, magma. The Moon would have been like a blazing inferno in the sky. Because the rock was liquid, even though it was rock, the gravitational pull of the Earth and the orbit of the Moon caused the liquid rock to have tides, just like the water on the Earth today.
Over time, the Moon and its lava tides cooled into a solid, desolate landscape, but the gravitational relationship between the Earth and the Moon has never ceased. Imagine if there was no Moon making an appearance each night. How different a world would it be? We're always tied to this mysterious orb we call the Moon. But what would have happened to Earth if there were no Moon?
The fact that we exist today is in part due to the Moon, allowing the Earth to create.
All right, guys. Well, hopefully you have enjoyed this. Hopefully you've taken something from it, and hopefully it gave you a visual, and yet another visual, as to how the Earth's tides operate with regard to being pulled by the Moon. So I hope you guys have a great day. I hope you've enjoyed it, and I will see you all in the next video. Take care, guys. Bye.